Welcome to Dev Bootcamp Live, the podcast where we help you level up so you land your first engineering job and become the best engineer on your team. I'm Juan Lizarazo.
And I'm Jared Potter. And today, Juan has brought us a really exciting topic. Juan, what is the topic we'll be talking about today?
Okay, so something that happened in one of the last few sessions of the year with my students is that there were some mutations and some variables being passed around, some global variables being accessed. And this was with React. Like, I mean, you can still make these mistakes, right? Depending on your configuration and stuff. So I was just thinking that we should talk about pure functions and everything that relates to it, right? Like there's so many things that relate to it, but all the benefits, especially in JavaScript, I have found throughout the years that is very beneficial when it comes to JavaScript because of the nature of the mutability of our objects and all the things we're going to cover today. So, Jared, to start, pure function. I mean, this is like a fancy term we probably hear at interviews, right? Sometimes they ask us those things. So, what is a pure function?
Yeah, definitely. So, one small bit is that pure functions don't just exist in the world of JavaScript, right? They can exist in pretty much any other programming language. Some of the details might be slightly different, right? But for the most part, everything is going to be pretty applicable. So, a pure function at its highest level, it is a function that has two specific attributes. One attribute is that the return value that comes from it, and a pure function does return a value, the value that gets returned will always be the same for the same inputs. Okay. And we'll get into more of what that means in just a little bit here. And then the second attribute about pure functions is that there's no side effects. Okay. And again, we'll get into what side effects are, but it's really important that if there's a pure function, it means that there's no side effects, right? So again, we'll get more into this, but there's a whole bunch of interview questions around these kind of two attributes and around pure functions that we're going to get into. So Juan, let's kind of get started. Let's get into it.
Yeah. Okay. So pure functions, we have inputs, right? Inputs, and you said like we have the inputs and then we don't have side effects. So let's just start defining like side effect. What is considered a side effect in a normal function? Let's say you have a function. What is a side effect in a function?
Yeah, so a side effect, which is not always a bad thing, just to make that clear, right? Sometimes side effects are very intentional, is generally it's going to be modifying some sort of state or some sort of variables outside of the function that you're working in. Is kind of the idea.
Okay, that's really good. And yeah, one of the problems I already see with that, even though like it's not a bad thing, when we work with or object-oriented programming, right? We are working with side effects. That's the way we program. Because, for example, let's say you have an instance of an object, right? You have an instance of a class, and that class has certain attributes, and one method, you call that method, and that method maybe is set name or initialize name, and then you initialize the name, right? And that name is outside the function because it's an attribute in the class. That's a side effect by nature. So we work with the side effects when working with classes, but one of the big problems with side effects, especially if we don't manage them early in our application that I have found is that when we have these side effects is that like for example, when we want to get to a desired state, maybe I don't know, Jared, if this has happened to you, but you're working on an application and let's say you're testing a specific bug or defect that you're fixing. And let's say to get to that bug, you have to do, let's say, 10 steps and then you test the bug, right? But then let's say you refresh the page and now you have to do again the 10 steps, right? It's because you have a specific environment, specific conditions. And that's really because a lot, it has to do with the side effects too, because sometimes we have to have the object in certain state and it's outside of what we're testing, right? Let's say we're fixing a function that is specific to doing something, let's say to showing the name, but then we have to first like, oh, we have to first like maybe set the age, initialize the, like all these other things that are external. So that complicates things. So that's like that. So side effects are not bad. We use them all the time, but like they can be unmanageable at some point if we don't take care of that. So thinking about pure functions, like what's the let's talk about a state, local state and global state, so we can start differentiating what a pure function is for our audience, so they can like think about it and like shape it in their minds. So let's talk about that. Global state, local state in a function. What is that?
Yeah. So an example of that is, when you're inside of, let's say, just a JavaScript file, whether or not you're on the back end in Node or on the front end on your favorite framework, or even just vanilla JS, any sort of variables that you're going to be defining at the either at the file level, or if you are building things into a class, right, into that class level, those are considered both global pieces of state. Another example of global state in the web world is the document object model, the DOM, right, that you actually interact with, right? And we'll get a little bit more into that. But those are examples of global states that are designed to be, in the place that they're at, to be accessible by different parts of your program. An example of a local state is going to be something that's generally within a specific scope, right? So when you see the opening and closing curly brackets, that's defining a scope. And inside of that is going to be some sort of local state, right? And you don't want that local state to interact with necessarily your global state outside of it.
Perfect. Perfect. Yeah. So if we imagine like the like giving an example of that, let's imagine we have a function that all it does is console.log the variable called name. But this function does not define name. This function does not receive any argument for name. And what it does is that this name is defined outside the function. So when we have a function like that, the function, let's say the function is called print name, has no control of what the value of the name is, has no control where it's coming from. So the problem with that is like, and this is what we call a side effect. Let's say I initialize the name as Juan in one part of the program, and I call that function, the result is going to be Juan, right? But let's say somewhere else in the program, we need the name to be Jared because we're going to view the user as Jared, just an example there. And then the name switches to Jared. Now, when we print again, maybe we're expecting Juan to be printed again, but now that's a side effect because we changed that function, but that variable, right? That variable that is outside our basic console.log function that we have, our block. So we have no control. So now it's going to print Jared, and we just introduced probably a defect to our program, right? Unit testing that is very hard because it's kind of like depends on external state, right? So that's what I like. Now we talk global, right? We can talk about external state. So when it comes to pure functions, you have your local state, right? That is just what you have between that scope, within those braces, brackets, and then you have the external state to the function. Anything that is defined outside that is not received as an input to the function, that's already external. That means that the function is not pure if the function accesses it or if the function modifies it. Accessing it, not as bad, is not pure already, but if you modify it, you are potentially adding side effects that you don't know about because you don't know who's using that somewhere else in the application. So that's already a side effect, and that's already bad. We consider side effects to be bad because they can be uncontrolled and unpredictable. So that's kind of like the basic example of what a pure function looks like. But because if I call, let's say, if I call this function 100 times, but let's say I change the name outside somewhere else, it could give me 100 different names, right? So it's not pure function. So one of the principles for pure functions is like, if you call the same function 100 times with the same inputs, if there's any input, you're going to get the same result, the very same result 100 times. And the function just depends on those inputs. So if we elaborate more, Jared, like on the pure function, let's talk about the inputs. Like what are the characteristics of these inputs? Because we can have an input, right? But let's say this input is an object, then the function might not be pure and we think it's pure. So let's talk about those inputs, the nature, what we need to keep in mind. How do we ensure that, that it's still pure even though we're receiving arguments, primitives? Let's cover all those aspects of our inputs for the pure functions.
Yeah, definitely. So when you are building like a pure function, generally speaking, you're going to receive some kind of arguments that are coming in, right? And the pure functions are very analogous to kind of a mathematical function. So imagine if you had a mathematical function of variable A and variable B, and you just wanted to add them together, right? Well, you would basically take in variable A, variable B as parameters into your function. You could then add them together with A plus B and assign it to a new variable called result, and then be able to return that result. And it's going to fulfill all the conditions that, what makes a pure function, right? There's no side effects. We're not modifying any sort of external state. We're not reading in any external state into the function. We're only reading in our parameters, and we're not causing any side effects. So to get into a little bit more of what Juan was saying about, things to consider is, with most primitive, well, with all primitive values, they're passed by value, meaning that even if you took these values in and then you chose to modify them, which that's another aspect of this. You don't want to modify the inputs, even if they are primitives and they are, modifiable without, affecting your external state. Generally, you'll want to, create your own new set of variables inside of your local state to manipulate. But when we talk about objects, that's kind of a tricky thing because objects in JavaScript and many other languages are passed by reference. So here's an example. Like, let's say that we want to, take in a person object, right? And let's say that we want to be able to, change their age or something like that. The thing is, we could do that, right? We could increment their age through like a birthday function or something like that. But the idea is that if we brought in that object and then we chose to modify that exact object's age, increment it by a year, the problem there is that we've just modified the external state of that function, which is not what we want to do. So in that type of case where you are receiving in an object, generally what you want to do is you want to be able to basically clone the object using some sort of cloning library, right? You can look into what kind of depth of cloning you need to do, or create a brand new object, right? And just copy over the fields that you need, and then return that new object to be assigned. And that would then make it a pure function there. So Juan, any other notes about that I missed?
Yeah, no, I think like key points when it comes to specific to JavaScript. um Never reassign parameters that you receive in a function. So that's some key points of this. Never reassign the parameters you receive, no matter what type they are. Never reassign them, right? You create always new ones, fresh functions. Always use let and cons inside your functions. So then that will ensure that you are scoping to the function. Because if you use var, there's a potential for hoisting, depending how you structure your function. Or if you don't use var, right, you're creating now a global function, you're bloating the global namespace. So it's even worse. You don't want to do that. So always use let or cons, depending on the variables you're using. If you're working with objects and you have to return, let's say you have an object like the user profile object and you want to modify the name, then what you can do is maybe spread, the spread operator, and assign the whole object to a new object, and then maybe just modify the name property, something that is very apparent, very familiar with Redux. Or you can use object.assigned, right? Or you can create a brand new object and then assign the properties you care about and then the new one, but you never modify the object you received. And that's going to prevent having side effects. How do you know if a function is pure? You think that, okay, if I send 100 times the same object, right, am I going to receive the same output the same 100 times? And you think about that as a test. And if that works, then that means that the function is most likely pure. Some other key point is that there's no this thing of like, oh, my function is half pure right now. It's either pure or it's not, right? So we don't want to get confused like, oh no, this function is sort of pure. That's good enough, right? Other point is that if you're working with object-oriented programming, you don't like object-oriented programming by nature is about side effects, right? You're modifying other attributes, you're modifying other things. So what you want to do is you want to combine things. So for example, let's say you can have some functions that are pure in your class, and those functions could be maybe private functions, internal functions that you're using, but then you can have those functions pure, and then that will keep things simple. Because remember, functions, you want them to do one thing and do it well, and writing code as pure functions will ensure you do that. Because if you have a function that is, let's say, capitalized name, right, and that function just does that, you can do it as a pure function, and then maybe some other function that is not pure because it's object-oriented programming is going to consume that function. So keep those things in mind. For unit testing, right, it makes it easy to unit test pure functions because you don't have to define all these different properties all over, right? You just said like, oh, this is the function, these are the inputs, this is the output, I'm done, right? You don't have to set up like, oh, I need to create this subject, now I need to get this state, now I need to set these other things that I don't care about, but I have to set them, right? So those are like key points for that. So Jared, I'm gonna go ahead and share our Twitters, and then let's continue talking. Let's talk about more about like applications of pure functions. What's the value? Why should we use pure functions? The benefits, functional programming. Like we have so much to talk about, and we're already halfway in the episode. So remember, with our podcast, you have homework. We're not going to turn you into an expert during the podcast. We expose you to topics, and then your mission is that you have to go and research everything you can about it, do examples. Like, this is a podcast audio only format, so we are not really sharing any screens or sharing anything, because this is in many audio platforms. So keep that in mind if this is the first episode you are ever hearing from us. So yeah, so I'm going to share here our Twitters.
Yeah, everybody can find me at twitter.com/Jared Potter. Feel free to at me, tweet at me, and ask me a question or share what you're working on. I'd love to be able to see it.
Perfect. And you can follow me at twitter.com/Juan Lizarazo G, JUANLIZARAZOG. And this is super fast. So we have links of our Twitters on whatever platform you're watching this on or listening this on. We have links to our Twitter. So you can just follow us there, tweet at us, interact with us, and also subscribe and follow the platform. So then you can always get notified about new content that we're posting. We're posting weekly, even during the holidays, right? It's Christmas, and we're posting here new content because learning never stops. Okay.
Yeah.
There's no
So
excuse to stop learning.
picking up just where we left off, right? We're going to start talking about some of the specific benefits of why you should write pure functions in your code. So Juan already mentioned one of them here, which is that one of the best benefits of using pure functions is that they're very unit testable. It's really easy to write unit tests around them, provide all sorts of different inputs, positive inputs, negative inputs, and really just test the heck out of these functions to ensure that they're doing exactly what they're doing. And it also forces you to, to another point Juan was getting at, is that it kind of forces you to write simpler, smaller functions, units that are, again, more easily testable. So to go a little bit beyond that, though, when you are using pure functions, one of the best benefits is that it basically knocks out a whole set of bugs, of potential bugs that are involved with some sort of shared mutable state. You can go and look up what those are, as part of your homework. But there's a whole bunch of different bugs that are associated with shared mutable state that you can just simply avoid by choosing to write your functions in a certain way. And again, not all of your functions are going to be pure. That's fine. That's just that. I mean, that's just the reality of how software ultimately works. But if you can learn to identify different sections of your code and be like, hey, this would be great for in its own function, and better yet, it could even be its own pure function. So that's another benefit. Juan, there's a couple other ones. What are some of them off the top of your head of why to use pure functions?
The one I want to emphasize that you mentioned is that it keeps things simple, like emphasizing of that, like functions have one responsibility. They should do one thing and do it well. They shouldn't be super long. Like if you have a function, I mean, there's not a hard number, but if you have a function that has 100 lines, the function is doing too much. And I guarantee you, a pure function is not going to have 100 lines. So it keeps things simple, because maybe you create a pure function that maybe maps the name, then another pure function that capitalizes the name, right? And then one of the things is that you can compose them. And this is what opens the door to what's called functional programming, where, for example, let's say I have, let's stick with the name, right? The big benefit of this. And this is one of my favorite parts. Sometimes like I have hard problems, and then I find that, okay, this hard problem, maybe I have my name and I have to like the name, and I have to maybe capitalize it and then format it in a special way. Let's say I have to split first and last name or something like that. So you can create a pure function that, let's say, it splits the name and the last name, another pure function that capitalizes the first letter of the word it receives. Let's say another pure function that maybe joins it again. Just say a simple example. It's a silly example, but just a basic example. So I could create these three pure functions, but then when I'm calling it, like consuming it, I don't want to have to think about like, oh, I have to call this one, this one, this one, an order or be specific. So I can create another fourth function that is not pure. Well, I mean, it's pure, but it depends on these other functions, and it's a compose function. So this function will invoke the other functions, or it will join the outputs of the functions, like in like a series, and that's how functional programming works. That's one of the nice things about functional programming. For functional programming, usually you will use some basic library, like for example, you can use underscore or Lodash, and you can use the function called compose. And that function, you can use it to you pass a set of different pure functions in that function, and that compose function will return a brand new function that does everything the little functions do. So it's really cool. I mean, I would say like go read about that, read about compose and functional programming, and you will see how you can split a complicated problem into smaller little problems. But the nice thing is that you can make these functions private and anonymous, so you don't even have to unit test each of those, because the compose function is a pure function on its own. But instead of writing like all these steps and complicating it, you just send input, you test the output. So I would say, let's say I would send Jared Potter, and I would expect in my test that Jared Potter is separate and capitalized the way I expected it. And I don't care about like what's happening in the internals. So that's one of the big powers. So let's talk more about functional programming, Jared. Like anything extra you would like to share, like high level?
Yeah, just to add a little bit more to what we're talking about here. So due to that simple nature of the functions, the forced simple nature of them due to writing pure functions, it's also really great for parallelized tasks, because there's no shared mutable state. There's no concern of race conditions, right? And you can Google race conditions and learn what they are, and be thankful that they don't exist too often in front end JavaScript world. And then the other bit about using pure functions is that it makes the refactoring a lot easier, as well as the portability of the code, right? So I know that there's times where, I work on a lot of different personal software projects, and there's times where I need, a few functions that I used in another project. And, sure, I could like create some sort of shared repository and put them there, but sometimes all you need to do is just grab those functions from that code, copy them and paste them into here where I need them. But because, they're pure functions, they've been unit tested, I know that they're going to be reliable, in that project and in this new project, right? So that's one of the also really nice things, is that you can end up reusing a lot of your code if you choose to write them in a pure way.
Yeah, you can just throw them in an npm package or in a GitHub repo that you can always install through npm, right? And on your other projects, you can have utility classes. Like one of the things I do a lot with pure functions is for writing my utility classes. Like an utility class, let's say I receive a payload from an API and I want to format it in a format that my front end component understands, right? Because it's not the same. I'm not coupled to those contracts. So I have a utility function, what I call a helper, right? I have a helper class that I put a bunch of functions that are related or grouped by concern, for example, formatting the user profile or something like that. So I can have some helper that is pure, and because it's pure, I create specifically these functions as a static methods. So a static method, those are methods, I mean, high level are methods that you don't have to create an instance before you can use it. You can use it directly in the class, and because they're static, there's no instance. There's traditionally no need to have a state. So it kind of forces you a little bit. I mean, you can still break it and not make it pure, but it forces you to be pure because there's no instance. So you don't have to create an instance of that helper class and then to use the method, you know that the method has no state. So it's highly unit testable and portable. So that's are like applications that we use a lot in front end to group things that are reusable. Let's say a basic example in an application, you are formatting dates. Let's say, you could use moment, but these days you shouldn't be using moment anymore. Moment is like, there's newer things to use. But let's say you have a basic date format that you need, and you don't really need a library. You don't need moment or whatever library you use. You can have just a helper function that you can use, receives the date and it formats it the way you need it, right? That could be a utility function that you can have a helper function, and that could be like a date helper, right? And then date helper dot format date, format year, format calendar, right? You can have these functions and they're highly predictable because they're shared, right? So it makes it really nice, and you don't depend on instances. But yeah. So for functional programming, Jared, like if we think about that, like there's this thought, like there's people that think that everything should be functional programming, right? Like they just want to like, I want to write, but I just want to be clear that um you like sometimes there's some problems that doing just functional programming is harder. So my recommendation is like you can have you can have the best of both worlds, right? If you're working with React or Angular, by nature, those are using objects, right? And object-oriented programming. So you can use some functional programming for internal problems you're solving that are hard to solve, like with other traditional methods, right? You can have the purity, the predictability, no side effects, but then you can still use it inside object-oriented programming. So you don't have to be like, oh, I want to do functional programming. So the takeaway for that would be like, go learn everything you can about functional programming and then apply it the way you like, that you see that it can be very beneficial for you and the teams, and not don't use it just because of the sake of using it.
Yeah.
Other benefit, Jared, for pure functions, so besides the side effects, the predictability, right, all this stuff, is that like there is this technique that we use, like if you work with Redux or NGRX or NGSX or what's the one for Vue, the state management.
Vuex or Vuex, depending
Yeah,
on who
exactly.
you
Okay,
are.
so if you're using any of those, one of the things, like probably these terms sound familiar to you because by nature, like the reducers, they are pure functions by nature because you don't mute the state. You always return a new snapshot of the state and you reuse pieces of the state, but the ones you modify, they're always new references. So, but one of the big benefits is that sometimes your state is bigger or your application grows, and maybe getting certain slide of the state as slice of the state is a slow operation. So there's this technique called memoization, right? Memoization. I don't know if I'm saying it right, but I don't use that word a lot. But memoization, that's a technique you can apply to pure functions. Because remember, this is really cool, Jared. I don't know if you know about this, but we use it a lot. When you create those selectors, if you create selectors with Redux, you are creating, you can create memoize selectors. And what they do is that if you're receiving the same input, right? You know that the output is going to be always the same because it's predictable. So memoization, what it does is that it creates a cache for that. So the next time you request, let's say, that user profile from your state, it will say like, oh, I already have it. It just returns it right away. And it doesn't even read it from state. But if the state changes and affects that key, it's going to invalidate that cache and it's going to update it again. So memoization really increases the speed a lot. I've used it and I have gotten a lot of like performance increase when I'm creating my selectors, depending on the complexity of the application. If you're using a lot of selectors and things, maybe your state model is not correct. Maybe you're doing too much in global state, right? You want to limit those things, but that's another big benefit of using pure functions. But ultimately, you're gonna write cleaner, predictable code, and in JavaScript, because JavaScript is mutable by nature, then it will benefit you greatly. So
Yeah.
I don't know. Do you have
Well,
anything to add to that, Jared?
yeah, just one note is that in the Vue.js world, they have something called computed properties, which are doing the same thing as these selectors that Juan's talking about here, where essentially, you know, the computed property might have a value that's based on other values. And, you know, when the state changes, it'll compute it, but then it will also cache it for performance reasons. So the next time that it asks for that particular value, that computed property, whether that's coming from a state or even just the local component, it'll just come right up, which is really convenient and nice for sure.
Let's talk. Yeah, no, that's really nice. I'm not familiar with Vue, as you know, but that's I think I have read a little bit about that, the computer properties. But computer properties are common in other libraries, so it's like a common good pattern. So go and read about computer properties too. That's something that you probably will use at some point, or if you work with observables, or like if you will benefit from it. Another thing that, like, we have talked about mutability, but we haven't like really defined mutability. I've been saying like objects are mutable, right? By nature. So let's define that, Jared. Like, let's talk about this. We mentioned this in another episode, but like just to wrap it up, like, let's say I create an object as a constant. Let's say constant user equal an object, curly braces. I have name, Juan, age, my age. And let's say I have that, right? And it's a const. I cannot modify, right? But we already defined in another episode that a constant, you cannot reassign it. I cannot reassign that profile to a new object, but I can change it. I can modify the profile.name to be Jared, and it's going to mutate that name because the properties are mutable by nature for an object. So mutability, right? Well, let's define that. How would you define mutability, Jared?
Uh, I mean, pretty succinctly, it's just that it's something that can be changed, or is designed to be changed.
It's designed to be changed. And that's the thing. Objects are designed to be changed by nature. If they were not, let's say you create a frozen object, you can do something like object.freeze, and you can create a frozen object, and that object cannot be mutated once created. But like Objects are mutable by nature, like maps, sets, arrays. They're mutable by nature. They're created so then you will mutate them and modify them, push items, remove items, find items, right? So those operations like adding, removing, modifying, right? It's designed to be that way. So having these concepts of pure functions and this good understanding about everything that we talked about today will help you get the most out of those objects, because then you will not fall in the common mistakes and you will ultimately write better code. So I just wanted to clarify that about mutability, and it's not a bad thing. They're designed, but if you apply these other principles, your code will be more powerful. So yeah, that's really it for today, Jared. I think, do you have anything else to add? If not, then I think we're
Yeah.
done.
I would just, I think a good way to end this would be to, just be aware of some types of interview questions you might get asked. So you might get asked, what is a pure function?
Right.
Or, they might write down on the whiteboard an example of a function. They'll ask you, hey, is this pure? Is it not pure? If it's not pure, why is it not pure? So I would just, maybe do some Google searching of some pure function interview questions,
Mhm.
and just make sure that you can, understand what they are, how they work, and when they're pure or not. And then beyond that, also make sure you're going out and actually practicing this, right? Next time you are writing a piece of code that could be in a function that is pure, right? Clean inputs, do something and have clean outputs, do that.
And the function can be pure even if it is inside a class. You can write a pure function. So don't get confused that you have to write it as a standalone function, like you see in a lot of examples. You don't have to do that. Other interview questions, I mean, you told the most common ones, but what is a side effect, right? What is mutability? What does it mean passing by reference? What does it mean passing by value? What does it mean, like, what is it when you mutate an object? Why side effects are bad? Um, does Redux use side effects? What is memoization? Like, all these are common questions that can come up at interviews. I have been asked some of these questions myself, right? Like, I've been asked those. So they are common, especially in the JavaScript world, especially if you're doing React and Redux or Angular and NGRX, like, because it's common patterns that we apply in JavaScript because they help you write a scalable software. But yeah, no, I think this was an awesome episode, Jared. So yeah, thank you so much for joining us today in this episode of Dev Bootcamp Live. I'm Juan Lizarazo,
And this is Jared Potter.
and we'll see you next week.
Take care, everybody.